Physics 2212, Lab 2, Charge Tape Revisited. Okay, so here's an overview of the things we'll be going through. So I got an intro slide, the physics principle I used, experimental procedures, my goal script code, results and what it means, and what ifs, and then possible sources of error, and my conclusion. So the purpose of this lab was to take what we know from lab 1, but here we assumed that the tape is a line charge instead of a point charge. We want to treat the floating piece of tape having an equally distributed charge across it, as opposed to a point charge right down the middle from the last lab. This charge, which is equal in magnitude, is distributed along the entire length of the tape. Some goals of this experiment include trying to determine the electric field of a charged piece of tape, finding the charge of tape pieces by having two charged strips interacting with each other, and writing a code in Go script that can be used to model the experiment and calculate the charge of the tape pieces as an evenly distributed line charge. Okay, so here are some physics principles that I used. So one that I use is polarization, which is the result of certain electromagnetic radiation, which occurs when a neutral object interacts with a charged object. This causes the neutral object to be polarized due to temporary dipole. So I also included the induced and permanent polarization formulas up there. And then opposite charges attract and like charges repel. That's a basic physics principle. And then I got the gravity force, which I included below, the electric field, the superposition principle, and then also which is useful for the tape, which is dividing the object into a series of point charges, like we did for this lab. So this is the lab procedure. So we used the same setup as lab 1, where we had two pieces of charged tape and attached one across two books, and then brought the second piece of tape close below the hanging piece and observed the hanging tape floating above the charged tape below. We also assumed that in order for tape B to float, the force of the electric field, tape A, must be equal to the force of gravity on tape B. So these two images below are just from the lab instructions, and then this is just from the first lab of us performing the experiment. So this is my Go script code. It is a little bit small, so it's a little hard to see, but I did highlight the important things such as my mass, my Q, and then here I've calculated my my values here, and over here I got my electric force and gravity force, or force of gravity. And so here are some results. So I got R to be 0.0175 meters, which points in the y-axis. I got the mass of the tape to be 0.0023 kilograms, and then the electric force to be 0.00266 newtons, and the force of gravity to be negative 0.0026 newtons. So as you can see here, the electric force and the gravitational force both have the same magnitude. And so what if you had to each type of your tape as a single point charge, like in the previous lab, compare the estimated value of the charge you get when you use your experimental data to produce a point charge model. So if the tape was modeled as a single point, it would be less accurate and you would have a smaller charge due to a concentrated area rather than a sum of multiple charges found in a line charge. The point charge in lab 1 was 1.17 e to the negative 9 coulombs, and the line charge in lab 2 was 9.55 e to the negative 8 coulombs. So why do these estimates differ? So the lab 1 and 2 values are different because of the shape of the electric field changing from a point charge treated as a sphere to a line of charges. The line charge models in lab 2 is more accurate and closer to the actual charge, since the line charge better models the actual shape of the piece of tape. So here are some possible sources of errors. So maybe we had too much contact, which the tape piece is affecting the charge of each tape piece. And then the measurement errors involved in the setup of the experiment and the transfer of data into GlowScript. And in conclusion, the distributed charge calculation was likely more accurate, and this line charge accounts for the charge across the entire tape, which is a more accurate description of the situation. All right, thank you guys.